All right, this video is for Mr. Blitch's 6th period Algebra 1 class. Hello, everybody. We're starting a new unit, Unit 8, Systems of Equations, and this is day 1 of it. Let's review first. Do you remember how to graph a line on a coordinate plane? Say you're given the line y equals 4x minus 3. You want to notice that it's in slope-intercept form. So the y value is by itself, and then it's followed by an equal sign. We also call it y equals mx plus b form. The b tells us the y-intercept. The y-intercept is a point on the y-axis that your line crosses through. So b in our equation here is equal to -3. This is where you begin. So if we were to graph this line, we would start on the y-axis. Remember, here's y. So here's the y-axis. Where is -3? Right here. That's our starting point. The m tells us the slope. So our m in this equation is equal to 4. If we're thinking in terms of rise over run, when your slope is 4, you're going up 4, right 1 unit. So we're going to start where we placed our y-intercept at -3, and then we're going to go up 4 units. So just like a board game, you're going to go up 1, 2, 3, 4, and then you're going to go right 1 unit. So count, put your pencil where your dot is at -3. We're going to go up 4 units. 1, 2, 3, 4. Right now your pen should be on the y-axis at 1. Then we have to go right 1 unit. So we're not going to put our dot until after we go right 1 unit. Right there. So there's our next point. So we have 2 points where we started at 0, -3, and then we just used our slope to find another one at the point 1, 1. Now that you have 2 points, you can draw your line. So you can use a ruler or a straight edge like your calculator and just draw a nice straight line. Yours will probably look a lot better than mine. And don't forget arrows. All right? So that's a review of how to draw a line in slope-intercept form. Now, remember how to graph a line that is not in slope-intercept form. We're going to go ahead and graph it on the coordinate plane above, so we can graph it in the same area. That's okay. Here we have 8x plus 4y equals 12. So one thing you can do when the equation is in standard form, which is also called ax plus by equals c. First, we're going to move the x term using subtraction or addition, depending on whether the x term is positive or negative. So I'm just going to rewrite, first of all, 8x plus 4y equals 12. And we're going to follow the first step. We're going to move the x term. Okay, so we subtract 8x from both sides. Cancels out over here, leaving us with 4y on the left side. And then we have 12 minus 8x. Those are not like terms. And so that it looks more like slope-intercept form, I'm going to write -8x plus 12. I'm also going to show you a way to do this on your calculator later, but this is good algebra practice. Now, number 2 says divide all terms. This step number 2 says divide all terms by the coefficient of y. So our coefficient in this case is 4. The coefficient of y is 4. So we're going to divide everything by 4, and that's going to get y by itself. So now our equation looks like the one from the review. We have y equals -2x plus 3. What is m? What number is multiplying the x? -2. So there's our slope. M is -2. Our y-intercept b is 3. So see if you remember, what do we start with? Do we start with the slope or the y-intercept? You're going to start with the y-intercept. So if we go up to our graph, we're going to plot +3 right here on the y-axis. And we're going to use our slope. This time it's -2. So we're going to go down 2 units from our y-intercept and right 1 unit. So down 1, 2, then right 1, and here's another point. What do you know? It's intersecting our other line. That's interesting. Just a little heads up, today we're learning about systems of equations. This is where we have more than one equation. So by reviewing, we've also introduced the topic for the day. We have 2 lines here, and they intersect in 1 point. They intersect each other right here at the point 1, 1. So the solution to our system is the point where x is 1 and where y is 1. So we're getting ahead of ourselves a little bit, but that's all right. You might see that. Awesome if you do. The system of equations is where you have 2 or more equations on the same coordinate plane. The solution of a system is the point, remember a point is an x and a y, where the lines intersect. So let's go ahead and do these examples. So I've gone ahead and graphed the 2 lines. They're both in slope-intercept form. If you need to review how to do that, you can go ahead and watch the first part of the video again. But we have our 2 lines here on the coordinate plane, and now we're looking for the point where the 2 lines intersect. Where do they cross? Right here. And that is at the point where x is 1 and y is -2, so that's the point 1, -2. The solution to our system is 1, -2. Go ahead and try number 2 on your own. Go ahead and hit pause. Try this on your own. And then when you're ready to check your answer, hit play again. And see if it matches what I got. So your graph should look like this. And your solution should be the point 4, 2. X is 4 and y is 2. All right, good job. Now, for problems 3 and 4, they're a little different. It's the same idea. You're going to graph the 2 lines and look for the point where they both intersect. But what do you notice about the 2 equations? The y values are not the same. I don't mean not the same. Sorry, my bad. Start over. The y values are not by themselves. Okay, so the y values in problems 1 and 2 were isolated. Meaning y was by itself. Here, y has company. You have -1/2 x on the left side as well. In this equation, y also has company on the left side. You have -x. So the idea is that we want to move everything away from the y over to the right side, so that y is all by itself on the left side. So I'm going to manipulate the 2 equations, and then we're going to go to our calculator, and I'm going to show you good ways to find solutions using your calculator. So first thing you should do is put parentheses around whatever you have over on the other side of y. Okay, so in this case, we're going to put parentheses before the -1. Next, what we're going to do is add 1/2 x. Why are we adding 1/2 x? Because to move -1/2 x over to the other side, we would add 1/2 x. After this step, you're going to close your parentheses, and then we're going to divide by the coefficient of y. In this case, it's a 1. So, while it's not really going to change anything, just to be consistent, we're going to divide by whatever the number is that's stuck on the y. In other words, the coefficient of y. Okay? We're going to do the same thing with our second equation. We're going to put parentheses here. We have -x on the left side, so we're going to do plus x. Okay? If it's a positive, you're going to subtract. So you'll see that in other examples. After you're done moving the x term, you're going to close your parentheses. Make sure you remember to open one for the -3. Now, after you close the parentheses after the x, we're going to divide by y's coefficient. Again, it's 1. All right? So now I'm going to show you what we can do in the calculator. So I want to see everybody doing this on their calculator. First, we're going to go to y equals. And then we're going to type in our two equations the way we set them up. So first we have to open parentheses, -1 plus 1 over 2x. If you want to use alpha y equals enter for the fraction, that's great. Put the 1 on top, 2 on the bottom. Don't forget the arrow over and put your x. Then you close the parentheses, divide by 1, and now we're going to graph the second equation. So we're going to open up parentheses, type in our -3 plus x. We're going to close the parentheses and divide by 1. All right, so we're going to use our calculator to our advantage here. We're going to hit second, this blue button, and then the trace button. We're looking for the point, or the point where the two lines intersect, so we're going to choose number 5. Be patient, let them graph, and then we're just going to hit enter 3 times. Enter, 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 and there's our solution. The intersection is where x equals 4 and y equals 1. For problem number 4, again, y is not by itself. So we're going to do the same thing that we did in problem number 3. Open parentheses before the 5. Since 3x is positive over here, we're going to subtract 3x. Then you close your parentheses. And then we have to be careful here. We're dividing by -1 because that's a -1 in front of the y. So that's why we divide by -1. In the second equation, again, we're going to open parentheses, type in the 15 that's already there. We're going to subtract the x term, close the parentheses, and we're going to divide by the 3 that's stuck on the y. So now go to y equals on your calculator, and we're going to do the same thing that we did in problem number 3. This is what it should look like in your calculator. Now we're going to use second, trace, 5, enter, 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 and there's our solution, the point 3, 4. So our next page says the multiple choice strategy. If we had a system of equations, and we're given 2 equations here, 2x plus 5y equals 8, and 6x plus 4y equals -20, and then one of the points listed here, A, B, C, or D, has the point that we're looking for, the point where these 2 lines will intersect. Remember, a point is made up of an x and a y, right? Notice that both of your equations have x and y. So one thing you can do is use substitution and put each point into the equations, and you're going to